Hello everyone, this is week 15 Monday and we'll be looking at economic order quantity again. We want to see if this model is justified to be used all the time because we know that demand is not constant. For example, we know what happened with the demand for toilet paper during the coronavirus pandemic. So because of that, Peterson and Silver in 1998 recommended for us to have some calculations and estimations just to see if the economic order quantity model is suitable or not for prediction in ordering. So we need to calculate three things. The first one is called average demand, and it's denoted by D bar. And if we have a period with a duration n, and for this period we have different demands, D1 through Dn. If we sum those up and divide them by the length of the period, we'll have the average demand. The second thing that we need to calculate is the variance of the per period demand, which would be, we'll use the sum of the variance from the average demand divided by the duration of the period. And the third thing would be the relative variability of the demand that will denote by variability coefficient, or VC, which is equal to the per period demand D divided by the square of the average demand for the period. And just to know that if all of the demands during the periods are equal to each other, VC would be 0. And if VC is a very small number, that would mean that the demand is relatively constant. However, if the variability coefficient goes over 20%, the economic order quantity model would not be justified to be used, and we'll need to look at other models. So we have an example here that we'll need to calculate if it's justified to use the EOQ model or not for Bonita Bolt works. So we have the demand for 4 months. So let's start calculating the average demand, the variance of the per period demand, and the variability coefficient. So the first thing we're gonna calculate is D bar, which would be equal to the sum of the demands for the period and we'll divide this by 4 because we have 4 months in the period, which would give us an average demand of 100. The second thing that we will calculate is the variance of the period demand, which would be each of those months demand squared minus the square of the average demand and then we'll do this for all the months. And again, we are dividing this by 4 because we have 4 months, which would give us 1400 divided by 4, or the variance is 350. And now we need to compute the variance coefficient, which would be 350 divided by 100 squared, and that would give us the coefficient of 0.035, which in our case is less than the 20%, and we can determine that we can use the EOQ model for this particular question. Let's see what we have on the next page. So we have a different type of model that is called multiple products economic order quantity, and basically for this one we have a company that has several products, and one of them is the most popular, and each time some of the others are not as popular, but each time an order is received, some products arrive, some don't, but each time they pay a fixed cost and also a variable cost depending on what they have ordered. And how can we figure out what to order when, and in order to minimize the cost of ordering? So there is a method that was created in 2001, and we can use this method using Excel solver to determine how to this model. So a few things that we need to calculate is the number of orders received each year of each of the products. And we'll be assuming that because product one is the most popular one, it will be in each order. And afterwards, product two is the second most popular, product three is the third most, and so on. So given those values, we have a table in example 3.62, and we want to figure out Cigar City appliances, how they should order different TVs based on the demand that they have, the unit purchase cost, holding cost, and product order cost. So this is the Excel spreadsheet that Dr. Insko provided for this lecture. And as you can see, we have the annual demand for all three products. We have the unit cost, holding cost, and product ordering cost for each of them. We can calculate the economic order quantity for each of the products. And we know that, as you can see here, we learned this a few weeks ago. This is the square root of 2 times the product ordering cost times the annual demand divided by the unit cost and the unit holding cost. So based on this formula, we find out the economic order quantity for product one is 489.9. For product two is 154.92, and for product three it is 48.99. How to find out the orders per year is we have the demand and we divide it by the EOQ, which if you look over here, so that's why we find out that we need at least 24.49 orders per year for product one, 7.75 for product two, and 2.45 for product three. And based on all this information, we have created a solver model that we have right here. So I'll just go to solver, and see what the solver model is doing. So we want to minimize the total annual cost, which is over here, and this would be the sum of the main annual order cost plus all of the holding costs for all of the three products. So this is the solver. As we can see, we are minimizing the total cost. We are changing the quantity of production of ordered products 1, 2, and 3. And we have some constraints here, and I was a little bit confused. Why did the product 1 go from 1 to 50 orders and products 2 and 3 went between 1 and 10? And I walked into the book. I talked to Dr. Insko, and the truth is that it doesn't matter. It's just that solver is asking us to just put in a number. So even if we put, let's say, 20 here instead of 50, it will give us the same result basically. So based on this, let's see what our results are. So we see that we need at least 11.43 orders of product 1, 2 orders of product 1 per product 2. So every second order will get product 2, and every fifth order will take product 3. So that would give us orders per year for product 2 would be 5 orders, and orders per year of product 3 would be 2.29. So based on all this, we can see the order quantity, which would be our demand divided by orders per year. So over here, the same demand and orders per year. Then average inventory would be half of the ordering quantity for each of those. Annual holding cost would be unit cost times holding cost times average inventory. And annual production ordering cost would be production ordering cost time orders per year that we have for each of the products. So it's the same over here and the same for this one. And then based on these calculations, we find out that the total annual cost would be the sum of all those and the main annual order cost. Now working on week 15 Monday assignment, we need to determine if we can use the EOQ model in this situation for Fort Myers artificial air. So let's see what our variables are. So in this case, we have, I just copy and pasted that from the one before. So we have 100 plus 50 plus 150 plus 300, which would give us, again, 4 periods. It will give us an average of 150. The variable of demand would be 100 square minus 150 square plus 50 square minus, I'm sorry, 50 is here, minus 150 square plus 150 minus 150 square. And then for the last one, we have 300 and 150, which would give us a total of 35,000 divided by 4 would be 8750. And now to find the coefficient, we will divide 8750 by 150 squared, and the result is 0.88, which in our case is bigger than 20, and we cannot use the EOQ model for this question. So let's see our second problem. For this one, we'll need to use again the file that Dr. Insko provided and use solver to solve it. So I'm just gonna switch to Excel. So as you can see, and I'll show you the Excel solver screen in a little bit. We have 9 orders of product 1, and then we'll need 9 orders of product 2, 9 orders of product 3, and 1.8 orders of product 4. And again, this is based on EOQ, which is the square root of 2 times the ordering cost times the annual demand divided by the unit cost times the holding cost for each of those. So the economic ordering quantity for the first product is 500, 316 for the second, 447 for the third, and for the fourth is 74.5. And that gives us about 20 orders per year, which is the demand divided by the EOQ for product 1, 9.49 for product 2, 8.94 for product 3, and 6.71 for product 4. So based on those, we create those variables here, and by changing them, we want to find out how many orders of each product we need. And this is how the solver window will look like. So again, we're changing the variables between product 1, 2, 3, and 4. We're choosing product 1 to be delivered between 1 and 40 times, and products 2, 3, and 4 between 1 and 20 times. And like I said, those upper bounds do not matter. Even if you change them to a different number, it will have the same result. And again, we're using evolutionary method rather than the LP method that we have been using before. And based on this, we get the following results. We have main annual cost of $90,237, and then for the total annual cost, we are just adding those holding and product ordering costs. As you can see over here, actually, we're not including product 4. So let me just fix this. That needs to go to F24. So now we're including all of the products, and that would give you the total annual cost of $207,000, 214.44. I hope this was helpful. It was a little bit confusing for me when I start working with it. Thank you for watching the video and have a nice day.